Hello everyone, I am Stephany Rajeh and I will present to you today our work on hierarchy and centrality measures in complex networks. So hierarchy and centrality are two main research approaches used to quantify the notion of influence of a node in a network. Hierarchy is defined as a system in which entities are ranked one above the other based on some authority or status among the nodes, while centrality it uses different topological information to rank the entities. Both are used in many real-world applications, such as in organizations, biology, and ecology, where hierarchy measures are used to quantify the most hierarchical nodes, and in world airport transportation networks, social networks, and terrorist networks, where centrality measures are used to quantify the most central node. With this, we ask what's the difference between hierarchy and centrality if both aim to quantify the notion of influence. Several hierarchy measures exist, and the most popular ones are based on hierarchical decomposition, namely K-core and K-truss. The main difference between both is that K-core simply requires a node to have a minimum number of degrees for it to exist in the subgraph, while K-truss requires a node to have a minimum number of triangles for it to exist in a subgraph. In both cases, after the hierarchical decomposition process, they result in the core of the graph, where the nodes that exist there are the most hierarchical ones. Also, several centrality measures exist in literature, and we cannot say that one is better than the other because it all depends on the research question at hand. So, as both aim to quantify node importance, we pose three questions. Do hierarchy and centrality measures convey the same information? Does network topology affect the relationship between them if it exists? And which are the most orthogonal and most similar hierarchy and centrality measures? To answer the questions, we use 28 real-world networks with 6 centrality measures and 4 hierarchy measures, alongside 3 correlation measures and 5 similarity measures. So what we do to answer the first question is simply we take the network, and for each node we calculate its hierarchy and its centrality value, and we obtain a set where we compute the correlation and similarity between the two sets in a network. Among all possible hierarchy and centrality combinations. We obtained the following results. Those 6 networks, they show 6 different behaviors between the relationship of hierarchy and centrality. On the x-axis, we have the hierarchy measures, and on the y-axis, we have the centrality measures. There are two extremes. On one extreme, we have very low correlation between hierarchy and centrality, and on the other extreme, we have very high correlation between hierarchy and centrality. Accordingly, we cannot say that hierarchy and centrality measures convey the same information, answering the first question, as there's a very clear variability between the values. This takes us to the second experiment to see if network topology has a play in this variability that we see. So accordingly, we take each network, the value, or the correlation and similarity value, and we threshold them on a 0.7 value, and for each network we now have a binarized feature where we sum the features of the binarized network, and we rank the networks accordingly. Interestingly, we find that top networks have high density and high transitivity, while bottom networks have low density and low transitivity, and the middle networks have low density and high transitivity. Hence, yes, we can say that network topology is affecting the relationship between hierarchy and centrality. In order to prove the consistency of the results, we now take the feature vector of the network but with no thresholding, and we input it in the k-means algorithm, and the clusters that we obtain, they overlap from 60 to 94% with the previous experiment where we have top and bottom and middle networks. Hence, this proved the consistency of the previous results. And finally, to answer the third question, whether we have which are the most orthogonal and which are the most similar centrality and hierarchy measures, we use the Schulze voting method, where the network is considered as a voter and the candidates are all possible combinations between hierarchy and centrality. We find that the most similar hierarchy and centrality measures are LRC and current flow closeness, while the most orthogonal, the most different, are K-core and K-truss hierarchy with betweenness centrality. So as a takeout message, we can say that hierarchy and centrality are indeed not the same. However, they do meet at a point when we have high density and high transitivity in a network, which induces high correlation and high similarity among them. This makes us consider substituting one against the other for efficiency purposes. On the other hand, when we have low density and low transitivity, we have low correlation and low similarity between hierarchy and centrality, which makes them both candidates as a combination to combine the information of both in order to better assess influential nodes in a network. And thank you.